Tech Tuesday. My name is Dewiel, Senior Application Engineer. We meet here every week on a Tuesday to talk about technical issues with the Solid Edge and the other packages that we carry at CamLogic. This week we're going to talk about Solid Edge. We are in the Back to the Basics series. This is sheet metal, and we'll be covering that today. Now, just real quickly, just to let you know for some of the first-time folks, who is CamLogic? CamLogic is a Siemens business partner located in Oxford, Michigan. Been in business about 16 years. We do the engineering hardware and software for Ohio, Pennsylvania, Indiana, and Michigan. Our products can be best described in three different areas, and that would be the 3D scanning, the CAD, CAM, and the 3D printing. On the CAD side, we have NX, Solid Edge, FEMAP, and Teamcenter. As I said, we are a certified Siemens business partner. We also carry Esprit for CAM. On the 3D printing side, we are a Z Corp partner, which allows us to take that 3D model from the CAD package, dump it into the machine, actually print it out, pull that model out, hold it in our hands, take it to a trade show, a presentation, you name it. And then also in the scanning and reverse engineering side of things, even the inspection side of things, we have instruments such as the shape grabber and the roamer arm that allow you to go back and to laser scan a part that's already created and then throw that point cloud ultimately into a CAD package, start that process all over again, or you can even take parts as they come off the line, put them in, say for instance to the shape grabber, let the laser scanner check out that part to see if it's a good part, and then we can continue to produce the part. So we are talking today about Solid Edge, back to basics, and in general, as I said, this is a 5-part series. It's basically a day in the life of the designer. Is this the most complicated parts we'll ever work with? No. But these are the ones that were going to help us get us started and get us confident in the Solid Edge basics. We've already done parts. Today's sheet metal. Coming up later on will be assembly, drawings, revision manager, and simulation express. Today we're going to talk about creating parts in place. We're going to look at synchronous sheet metal. We're going to look at our patterns. We're going to look at flat patterns, DXF, and bend tables. So, without further ado, let's go get started. I've got an assembly here that I've already created, and right now it's just a motor. And I wanted to create some pieces, some sheet metal pieces. And what I've done is I've created a part in place. And that just allows me to give it a name right here in the assembly to tell where I want it to go and tell how I want it to start. Now, these parts have already been created. The base part has already been created. So as I'm here, I want to start under that motor. Now, I'm going to work in synchronous sheet metal, and the first thing I want to do is I want to insert a part copy, or excuse me, an inner part copy, and I want to take the whole body of this motor because I'm going to use it as I create my base part. I'm going to need that. Now, I don't really need this part of the assembly to show, so I can right-click in my radial tool menu and I can go hide previous level. So now we're just looking at this purple or magenta, if you will, set of surfaces for this motor, and this helps me to design. Now, what I want to do is I want to work right under here on this plane, and I'm going to flip this around just so we can see it quickly. And I want to create a base plate, and in this case I'm just going to maybe come over here, something like that, and just kind of lay this out. Again, if you've ever attended my classes, you realize that I'm not so much concerned about the dimensions as I am the function of the part. The dimensions certainly can drive the part, so we're not going to be hung up on that. Right there is 8.642 inches. I'm just going to say I'd rather have it to be 8.5 and just adjust it right there. So I'm not all that concerned about the individual dimensions of this. We'll make that 8 inches. I'm not concerned about that. More concerned about the functionality and being able to work with it. So I've got a region here, and I'm going to take this region and extrude this region down into my first base sheet metal. But the second I do that, my material tab comes up and allows me to pick the material I want to make this out of. In this case, it's going to be structural steel. And then also I want to go pick out my sheet metal gauge. In this case, we're going to hold a motor, so I want to go 10 gauge, 141 thousandths thick. And I'm going to apply that to the model. And then I'm going to take and pull that flange down just like that. Now, you can see that the length and of my part is fine, that everything's good, except for that the base actually now interferes with this cover. Well, I want to show you a really neat little trick inside of synchronous, and that is the ability to what's called project to sketch. Now, you might be used to this called include out in the ordered, but I think you're going to like this. This is project to sketch. So what I want to do is I want to work on this plane, but I just want to take this circle and I want the silhouette of it to project straight down to that point. Now, the reason why I chose that is because I want to take this and I want to jog this piece, and I want this piece to actually come down to avoid that cover, and I'm going to bring down to the bottom, and I want it to come down a good 1 inch. I want it to set it like that. So now my part's going to set the way I want it that way. Now, to that side, I want to take a flange, and I just want to click that face, and without using any more material, I want to pull down this flange, and I want to set it down as far as the bottom side of that. So I want to set that out just like that. Now, at this point, I'll go ahead and I'll measure this. I really wasn't concerned, and you heard me say that. I really wasn't concerned about this before, but I'd like maybe that to go 2 inches out and have that part run 2 inches out. Actually, let's go back here. Let's go back in time real quickly. Okay. I want to take this 8 inches. And I did tell it to lock it down. And I sure did tell it to lock it down. So I want to do a little bit of face relate now. I'm going to go out, I'm going to relate this face. Now, if you saw my mistake, what I did is I left this locked at 8 inches. And yes, I did bring this out 2 inches. And yes, that did stay at 8 inches. It did exactly as I told it to. So now what I've done is I've unlocked this face. And I'm going to make a face relate. And I'm going to say this face, yes, is going to be perpendicular to that face right there. There we go. So now we're going to have this come out. Now, I'm going to set this back to 2 inches. I'm going to hit tab, and I'm going to go lock it right there. So I want this to be 2 inches as I see that right there. Now, I'll take this face right here and pull this out, and I want to bring this out, and you guessed where I'm going. I want this about that far as well. I could have made it 2 inches, but the nice thing about this, the synchronous, is I can work on something even after it was created, and I can change the purpose of it even after it was created. this is 2, this is 2.276. I'm going to right click and I'm going to edit the formula, and the formula of linear number 3 right there is going to become the distance of that part. So now that's going to be 2 inches as well. So this one is going to follow this right here. That's going to be 2 inches and 2 inches. Now, I'm going to go ahead and turn my base reference planes on, and I'll take this flange and this flange right here, and I'll just simply pattern that flange about the center so we can have what we want. Actually, we'll take this back just a little bit. We'll do that one more time. 1, 2, and mirror it about that. Okay. I'm going to bring that around, and we'll attach it. Okay, we got a little technical difficulty here, which so far I've run 2 difficulties this morning. So we'll go ahead and fix that the same way, and just come down with the flange. How far down do I want that flange? I want it to come down as far as this over there. And then again, I want that to come out 2 inches over that way. Okay? So I've got this. Now, to this face here, I want to go add some holes, and we'll do the same thing. We'll go and project to sketch, and I'll just take, and I'll just choose to work out on this plane. I'll just take these circles, and you can see that just by working live right over here, very nice to just kind of skip that step that we normally have inside of the order. So I can move that and project to sketch, and I can actually, pick and turn and rotate with my 3D controller over here. So as I have that, I may take off and just simply hide that what I need right there. Now we'll go ahead and measure this, and I'll just find out that this dimension right here is 380. That's the diameter, 0.38 inches. So we'll simply just go out and place a hole right over there, and we'll size that. If that's 380, then I'm going to get a 405 hole. And where am I going to put that hole? 1, 2, 3. Now, I like holes rather than cutouts. When it comes to circles, you can do as you choose. I like holes rather than circular cutouts. I actually want to see that we're going to get a drill or whatever, and we're actually going to drill it. Or even if we punch it, I still like the idea of the hole. Contact me for further details if you are interested in my opinion on that. So I've got this piece right here, and I'm going to go pop that out into our assembly. So now that's setting right down there the way it should. Now, I'm not quite happy with this piece that I've got, so what I'm going to do is I'm just going to take this face, and I'm just going to lower this face, and I just want you to see how the live rules is going to go take all of them. No one ever said they were all the same height. No one ever said they were going to operate together. But the live rules goes out there and says, you want to move that, we're going to go ahead and move that. So that's going to give us a little better look to what we've got. All right, so the next thing I want to do is I want to work with the guard that we're going to put in. And again, I'm going to look at this, and I'm going to do inner part copy. I'm going to do 2 of them. I want this base and this piece, and I want the entire body of this piece. Right-click to accept, and then I'm going to simply follow it again. I want this piece, and I want the entire body of this piece as well. Now, I really only need faces of that, but I just want to be able to show you that you can do that. I'll right-click, hide that, and just work right out there. Now, I'm going to start this part out in synchronous sheet metal, and then we're going to transition to ordered for a few things. So I want to work with this plane right here. But what I want to do is I want to start back. So I've automatically created a parallel plane, and this plane is going to start back 3/4 of an inch. So I want to work on this plane, and I'll snap this up to it just so you can see what I want to do. Start down at the bottom with a line, and I'm going to come straight up, straight up. Now, want to do a few things right here with my relates just to show that you can use what you need to. I'm going to make the end of this leg as high as the center. If you like, I can make this leg and this leg equal, that giving us that. And then I'll start over here with a line, but I'm going to type in A, and I'm going to start an arc and just come around to there. Okay, so now I've got this piece setting out here. I've got this sketch, if you will, and I'm going to do a contour flange. And again, we're going to go figure our piece, and we're going to give it a 10 gauge structural steel. Apply that to the model. And then I'm going to just take this shield back 6 inches and have that shield set right out there. So now this shield's going to protect the motor from being stepped on or touched, and maybe the motor gets particularly hot during its operation, so we want to shield that a little bit, or things fall on it or whatnot. So we just want to shield this motor just a little bit. Now, I have already created this piece that it is going to be 6 inches wide. So let's go down and take this. I just want to show you this right here. This is 6 inches, and I'm going to lock that. So that's 6 inches. The nice thing about this is if I take this face right now, and I want to move that face, I want to take the face, drag my steering wheel to the center, and then I'm going to move this part. Even though I started on that plane 3/4 inches back, I can now move that part to anywhere I want. And if I'm looking for a key point, I can move it to a key point, or I can just bring that up just a little bit more, and I can adjust as needed. And as I'm adjusting the whole part, this understands that it stays at 6 inches. Okay, so now that I've got this part, I want to go out very quickly, and I'm going to go and I'm going to transition to ordered. Okay, so this is the same piece, but I'm now using the ordered workflow. And what I want to do in the ordered workflow is I want to take and I want to unbend. And I'm going to pick a face that stays straight, and I'm going to pick a bend that I want to unbend. We'll right-click, and Solid Edge will go ahead and unbend this piece. Now, to that piece, I want to put a simple hole right out here. And I want to go ahead and give it a dimension, and maybe I'm concerned that it's, we'll take that out in the clear, that it's 1 inch from the edge. And maybe I'm also concerned that it's obviously 1 inch from that edge as well. So we're going to go set that hole and drill that hole through. And the reason why I unfolded this is because now I want to take the hole and I want to pattern it, and I want to run it something like this. You can adjust this in any way that you like. I'm going to do a rectangular pattern, and in my case, I'm just going to bring this out. And again, just for the sake of time. You can adjust it any way that you like. I've got an 18 by 5 setting out there. What I might want to do is I might want to end it again 1 inch from the bend on the other side. So totally up to you how you want to run this. But the nice thing about this is I'm going to go stagger this, and I'm going to go stagger this pattern, and I'm not going to include the last row. You can adjust as you like. So when you see that, I'll have this row, and now that I've got this, I'm going to rebend this particular bend. And Solid Edge is now going to roll that out. I think I missed my stagger. Nope, I got my stagger. That's good. All right, so I'm looking at this. Now, to this piece of sheet metal, I'm going to go out and I'm going to run a drawn cutout. And a drawn cutout is just a simple hole with not all of the material removed. I'm just going to come out here and we'll size this 1.5 inches. Just to show you that this can be done, I'm going to bring this back about 3/8 of an inch. You can see now I've got a drawn cutout. Now maybe we run the cable through. Just in the basic idea of a drawn cutout, with this busted through the back, that keeps me from having a sharp edge from the cable to run on just the thickness of the material. So we're actually running that back. Maybe it gives you a little bit of strength as well. So as I have that, I can close and return and look out at my model. Now, I want to take this base piece. I want to go down to this base piece, and we're going to hide some sketches and hide our PMI, and I just want to see that piece in itself. I'm going to go to Tools, and I'm going to go to Flat Pattern. I want to create a flat of this, and I want this piece to stay up, and I want this corner to start at the 0, 0, and you can see how it's going to flatten out there. So this part, with what we've asked it to be, is 14, a little over 14 and a half, a little over 10 inches. So you can see the actual size that we want. By clicking back on the synchronous banner, it's going to bend right back up, telling me exactly what I want. Now, I'll do that in a different way. So we'll go ahead and save that. I'll do that in a different way with this piece, just to show you it can be done in multiple pieces. Okay, and we'll go ahead and hide our part copies. We just really want that. So we'll go ahead and take this as well, and even though I'm in the ordered flat pattern, I want this, I'm going to start down there, and we're going to flatten that piece right there, and it's going to give us exactly what we want, 23 and 6. So going back to the ordered, it's going to pop right back up. Now that we've got this, I'm going to save my file. And I'm going to go Save As Flat. And Solid Edge is going to make an automatic AutoCAD DXF right off of here. I want to show you the options. It's going to give us all of the layers, just like AutoCAD, up, down center lines, outer or up center lines, burn lines, outer loops, inner loops, and you can change the name of this if your burner needs to see anything differently than what we have. You can change the name. You can decide not to show certain layers. You can color certain layers. Certain layers don't even, in the export to DXF, certain layers don't even go out to the DXF if that's your choice. You can have anything that you like setting like that. So I'm going to go out and I'm just going to make a DXF right from there. Now, to go see that, I'll just go open the DXF that was created, and you can see that the DXF is created right there. Here's the colors a little bit different to see, or hard to see on over the web, but here's the outer loop. The outer loop, the interior loops, all of this right here is going to correspond to that layer mapping that we had set. So let's get back to this piece. Tell you what, let's get back to this piece very quickly. And while I have this piece, I'm going to go new, and I'm going to go create a drawing, and I'm going to allow the Solid Edge to create a drawing for me of this, and we'll kind of move this around, kind of bring this over. There's a few things I want to do. Go to my principal view, and I'll take this, and as I do it, I'll shade, and I'm just going to pull that up, and now we can see, this part, we can see how to make that part. And then I'm going to go out to my view wizard, take the same thing, and this time I'm going to go get the flat pattern, and I'm just going to take the top, and I'm going to say custom, or I'm going to say finish, and I'm going to put the flat pattern out here. Now this is not the DXF that the burn table is using, or the laser is using. This is not the DXF. This is for inspection purposes. This can be scaled any way that I want to. I'm going to half scale this. All right, so the laser is not cutting this set of geometry out. It's cutting out the DXF that we created earlier. So we can start to throw our dimensions here, let everybody kind of see what we're doing. And we'll go ahead and set our scale up here just a little bit bigger so everybody can see it. So everyone can see exactly what we're doing. If we wanted to come out here and look at the hole right there, we could go point those out, and then we could stagger them any way that we like. One nice little trick about this, automatic centers, you just got to love that. I'm not about to go out and draw every one of those center lines over those holes. So this is the beginning of the basics, if you will, of solid edge sheet metal, giving us the ability to go out and to create parts such as this base, such as the guard, inside of sheet metal that gives us the ability to make motor mounts, make containers, that type of stuff. All right, so we talked today real quickly about create in place, about synchronous sheet metal, how easy it is to simply create, and even you saw on my little flub up there, you saw on my ability to correct something or to change a design intent. We talked about patterns, making a flat pattern, flattening out that part, saving it out as a DXF, and then also creating some bend tables. So anyway, all of this that we're learning comes from our Solid Edge basic training course. And we offer that on site at your facility or in your town or even at our facility in Oxford, Michigan. So please contact us about the type of training that you need. This is a basic type thing. If you have more questions, obviously we can answer those questions for you. So today's webinar can be found out on YouTube. If you look at the YouTube, the Cam Logic channel, you'll be able to see our webinars. Again, my name is Dewiel, Senior Application Engineer for Solid Edge Technical Support. Feel free to give us a call, 248-969-9201. My extension is 6209. Dale D at camlogic.com. Anything that you need, give us a call. Also, just to contact us in general, the main switchboard, 248-969-9201. Well, thank you for your time. I appreciate